The electrical conductivity of a molten individual substance depends on the type of ionic bond that existed in the solid state. Salts with ionic bonds, for example chloride of alkali metals, are characterized by electrical conductivity in the molten state. When melts of substance with a covalent bond contact poorly or practically do not contact electric current. The electrical conductivity of molten salt is usually 1 to 2 orders of magnitude higher than the electrical conductivity of an aqueous solution of the same electrolyte. The electrical conductivity of most melts increases with increasing temperature. And for a number of salts correspond to the equation. Here the activation energy of electrical conductivity is taken into account, which is necessary for the ion to overcome the interaction with the surrounding ions and to jump into the vacancy. Due to the change in the structure of the melt with temperature, the corresponding dependence of electrical conductivity on temperature may be strongly distorted.